Hello. So as you have understood what is the concept of a normal measurement and control loop, now let us move to the control of normal body parameters like temperature, water levels and glucose concentration. Have you ever thought of why all these parameters are kept constant in the human body? For example, temperature is always maintained to 37 degrees Celsius, water levels are always maintained whether it's a summer or winter season, and the glucose is also maintained. So behind all these processes, the concept is homeostasis, that is negative control loop through the of the human body. So the body mechanisms works to maintain all the cells in a constant environment through this homeostasis loop. Now let us take an example of how the body temperature of a human body is controlled. Now all the mammals, they have a constant body temperature, and the human body temperature is generally around 37 degrees Celsius, as irrespective of what is the outside temperature. Now how it is taken care of? There are various effects, there are various processes behind this. The first is sweating. In case of summer or in case of higher temperatures, the sweat glands are stimulated, which releases sweat. Now this sweat is liquid that comes on the surface of our body, and it turns into a gas through the evaporation. For this evaporation, the energy is taken from the body, the heat is absorbed by the body, and that's why the temperature is maintained to a constant, that is the temperature is reduced. So through the heat loss, the body cools down. So here is the animation which shows this effect very nicely. So you can see that the normal temperature of the body is something like this. If the temperature increases, you can see the mercury is going up, and then there is sweat or the layer of liquid, it comes across the skin. And then there is a heat absorption from the skin which converts this liquid into gas through evaporation process, and that's why the body temperature reduces. Okay, so this was about the sweating. The next effect which is also effective or which also reduces the body temperature is called vasodilation. Vasodilation is the dilation or relaxation of various blood vessels. Now the heat is carried away from the body surface through the blood vessel or through the blood which is carried through the blood vessels. Now when the temperature increases, the blood vessels underneath the skin, they are dilated or their diameter increases, because of which the blood flow through that increases and the heat is taken away from the skin because of this vasodilation. Again, let us have a look at this through the animation. So here, earlier the temperature is normal. Suppose the temperature increases, then the blood vessel dilates. Because of the dilation, the diameter, as you can see, the diameter has increased and more blood flows through the blood vessels, carrying the heat away from the skin surface. So this is called as blood dilation, which reduces the temperature in case of higher temperature. Then what are the mechanisms that warm the body up? That means in case of winter season, what is the effect that you can see? This is exactly opposite to vasodilation, which is called as vasoconstriction. So vasoconstriction means reduction in the blood vessel diameter. So when the temperature of the body reduces, the blood vessels, they will contract, the diameter will reduce, and less amount of blood will flow through these vessels. And obviously, if it is less blood flow, less amount of heat is carried through the skin, thus maintaining the body temperature again to 37 degrees Celsius. So again, have a look at this animation. Initially the temperature is more. Because of the winter season, the temperature reduces, and then the blood vessel which was carrying the blood, it reduces in diameter, and that's why blood flow reduces, the heat loss is reduced, and the temperature is maintained. Okay, what is the another mechanism that warms up the body? That is called as piloerection, or in common words it's called as goosebumps or chicken skin. This is nothing but when you feel that the temperature is less or your body shivers, the hairs, they stand on the skin. This because of this, the air is trapped in the skin, which acts as the insulating layer, and it causes the reduction of the heat loss, or it reduces the heat loss, and because of which again the temperature increases. So here through the animation this is explored nicely. The temperature is more, the mercury reduces, that means showing that the temperature has reduced. The hair, they will stand up, and this causes the air to get trapped, causing or generating an insulating layer, and thus the temperature is maintained. Now let us have one more example which is related to controlling of glucose levels in the body. Now, as you know, when we eat some food, that food gets converted into glycogen in the liver. Okay, so this is regulated by two hormones in the pancreas, which are insulin and glucagon. So what happens exactly is, when you eat some food, there are the sugar particles which are stored in the blood, and if that is excess in energy, if that is in excess, then insulin will cause the glucose to get converted into glycogen, and that will be stored in the body. Now whenever you require more energy, the same glycogen will be converted back into the glucose through glucagon. So this is the action of the normal body, or this is the action for the normal healthy subject. But in case of diabetes patient, what happens is the insulin is not being secreted properly, and that's why, as you can understand, the conversion of glucose into glycogen is not possible. So because of which, in the graph you can see that for a normal person, after the meal is eaten, the glucose level increases, and after a certain time the glucose level comes down, or it comes back to the normal because of the conversion from glucose into glycogen because of insulin. But for diabetes patients, this is not possible. For them, after they have some food or they take their meal, the glucose level increases and it is maintained to a constant value. It doesn't get converted into glycogen, and that's why the sugar level in the blood increases. So for a diabetes patient, you can see that the conversion of glucose into glycogen is not possible because there is no insulin which is present, or the insulin is not being secreted, and thus obviously those patients, they have to take externally insulin dosage. So I hope you must have understood the concept of homeostasis for glucose and temperature control. Similar to this, other body parameters like blood pressure, pH, water level are also controlled through this homeostasis loop. So this PPT was taken from the website www.worldofteaching.com, which is a open software, or which is a open source. Thank you for listening.